Hello students, welcome back. First let us start Brahmanand. So today here we are going to study a new chapter, that is electrochemistry. So what is electrochemistry? So electrochemistry is the branch of science which deals with the relationship between electrical energy and chemical energy. That is, chemical reaction takes place as a result of when electricity is passed, or electricity is produced as a result of chemical reaction, that is the redox reaction. So this is the branch of chemistry which deals with the study of interrelationship between chemical energy and electrical energy. Okay, so as a result of chemical reaction, electricity is produced, and as a result of electricity being passed, chemical reaction takes place. So both the interrelationships study is known as electrochemistry. Okay, so before going this electrochemistry study this, let us know what are the different terms associated with it. So first, so electricity, that means it conducts by some substances. So first know what is your conductor. So according to the conductor behavior or conductance behavior, according to electrical conductance behavior, matter or substance classified into three types, that is conductor, semiconductor and non-conductors. So what are conductors? So conductors are the substances through which electricity can pass, or which allows electricity to pass through them, that are known as conductors. So the substances which allows electricity pass through them are known as conductors, and these conductors are of two types. One is known as your metallic conductor, and another electrolytic conductor. Okay, so metallic conductor. So these are the conducting materials. So these are the metals which conduct electricity. Metallic conductor. These are the metals which conduct electricity due to the flow of electrons, that are known as your metallic conductor. Like your copper, silver, iron, aluminum, etc. So these are your metallic conductor through which electricity can pass. And electrolytic conductor, so these are the conductor which allows electricity to pass through them in molten state, or in aqueous solution. So the substance which allows electricity pass through them in molten state or in aqueous solution are known as electrolytic conductor, also known as electrolytes or electrolytes. Okay, so generally all ionic compounds are electrolytic conductor. Maximum ionic compounds are electrolytic conductors. Okay. Next, what are non-conductors? So non-conductors, So these are the substances which do not allow to pass electricity through them are known as non-conductors. The substances which do not allow electricity to pass through them are known as non-conductors, and these non-conductors are generally non-metals and non-electrolytes. So non-metals, these are the non-metals which do not allow electricity to pass through them, like yourself, all inert gases and hydrogen, chlorine, oxygen like gases, all inert gases and all hydrogen, chlorine, oxygen gases, and some solid elements like sulfur, phosphorus, iodine, etc. Exception graphite. So graphite is a non-metal which can conduct electricity. So except this non-metal, all non-metals can conduct electricity. Similarly, non-electrolytes, these are the substances which in molten state or in aqueous solution do not allow to pass electricity through them are known as non-electrolytes. So non-electrolytes like your solution of glucose, sugar, urea, etc. So these are the examples of some non-electrolytes. The maximum non-electrolytes are covalent bonded molecules, covalent bonded compounds. Maximum non-electrolytes are covalent bonded compounds. Okay. So these are your non-conductors. Next, what is the difference between a metallic conductor and an electrolyte? Difference between metallic conductor and electrolytic conductor. Difference between metallic conductor and electrolytic conductor. So, metallic conductor and electrolytic conductor. So, in metallic conductor, electrons are responsible for the conduction of electricity. Electrons are responsible for the conduction of electricity, whereas in electrolytic conductor, ions are responsible for the conduction of electricity. In metallic conductor, due to movement of electrons, electricity can conduct, and in electrolytic conductor, due to movement of ions, electricity can conduct. In this way, this is for conduction, electrons are responsible, and here ions are responsible. These are all known as also metallic conductor, also known as electronic conductor, because electrons are responsible for this, and electrolytic conductors are also known as electrolytes. Okay. Next, here no chemical reaction takes place. In metallic conductor, while conductance takes place, no chemical reaction takes place, but in this case chemical reaction takes place. Chemical reaction takes place. Okay, so this generally in case of electrolytic conductor, when conduction, that is chemical decomposition takes place. Okay, chemical decomposition, no chemical reaction takes place. Next, no transfer of matter takes place. Here no transfer of matter takes place, and here transfer of matter takes place. Transfer of matter, as chemical reaction takes place, then transfer of matter takes place. Okay, so in this case, in metallic conductor, generally the conductivity is high, the conductance value is generally high, and in this case the conductance value is generally low. So electrolytic conductor, the conductance value is generally low. In this case, metallic conductor, the conductance value is generally high. Next, with increase in temperature, the conductance value decreases. So with increase in temperature, so decreases with increase in temperature. So this conductance value of metallic conductor decrease with increase in temperature, while in case of electrolytic conductor, the conductance value increase with increase in temperature. So with increase in temperature, this electrolytic conductor increases, while in metallic conductor with increase in temperature, this conductance value decreases. Okay, so these are the main difference between metallic conductor and electrolytic conductor. Another thing is metallic conductor generally obeys Ohm's law, and electrolytic conductor obeys both Ohm's law and Faraday's law. So these are the main points of difference between metallic conductor and electrolytic conductor. Okay. Next, come to what is this electrolytic conductor? Electrolytic conductor. These are also known as electrolytes. So, the substance which conduct electricity to pass through them either in molten state or in aqueous solution are known as electrolytes or electrolytic conductor. And these electrolytic conductors are generally, these electrolytes are generally classified into two types. That is depending on the extent of ionization. You know, generally in electrolytic conductors and electrolytes, the conductance takes place due to the movement of ions. So in this way, how many ions they can give depending on these electrolytes are classified into two types. One, that is your strong electrolyte, and another weak electrolytes. So the electrolytes, all this depends on the degree of ionization, or we can say the degree of dissociation, which is expressed in terms of alpha. And what is this alpha? That is your number of molecules splits into ions divided by total number of molecules dissolved. Total number of molecules dissolved or total number of molecules present. Total number of molecules dissolved in aqueous solution, or if you take the molten case, total number of molecules present. The number of molecules splits into ion divided by total number of molecules. This is known as your alpha. So depending on this alpha value, these electrolytes are classified into two types. One is strong electrolyte, another weak electrolyte. So the electrolyte which ionizes almost completely, the electrolyte which ionizes almost completely, or this alpha value is nearly equal to 1, that are known as your strong electrolytes. So strong electrolytes which ionizes almost completely, or you can say alpha value here it is nearly equal to 1, which ionizes almost completely, or the alpha value, degree of dissociation value is nearly equal to 1, that is known as a strong electrolyte. And generally, what are the strong electrolyte? Strong acids, strong bases, and salts. Strong acids like sulfuric acid, nitric acid, hydrochloric acid, etc. Strong bases like sodium hydroxide, potassium hydroxide, barium hydroxide, etc. Salts like sodium chloride, potassium chloride, potassium nitrate, sodium sulfate, etc. So all salts, strong bases, strong acids, these are strong electrolytes. Okay, and weak electrolytes, in case of weak electrolytes, this alpha value is, so the electrolytes which ionizes feebly or which ionizes up to a very small extent, which ionizes very slightly or to a very small extent. The electrolyte which ionizes to a very small extent, that is known as your weak electrolytes. And here the degree of dissociation value is very less than 1. So alpha value is less than 1. This is nearly equal to 1 and this is very less than 1. And what are the examples? That is your weak acids. These are known as your weak acids like acetic acid, oxalic acid, or formic acid. All these are organic acids, maximum organic acids. These are weak acids. Similarly, weak bases like ammonium hydroxide, calcium hydroxide, etc. So weak acids and weak bases, these are weak electrolytes, while strong acids, strong bases and salts, these are your strong electrolytes. They ionize almost completely and they ionize to a very little extent. Okay, so these are your strong electrolytes and weak electrolytes. So as this is the chapter of electrolytes, next let us know another term, what is known as electrolysis. So what happens to the electrolytes? Next come to another term, that is electrolysis. So what is electrolysis? The chemical decomposition of an electrolyte by the passage of electricity is known as electrolysis, or we can say the movement of the oppositely charged ions towards the movement of different ions towards oppositely charged electrodes on passage of electricity is known as electrolysis. Lysis means breaking and electro means electricity. So on application of electricity, the molecules splits. On application of electricity, the molecule splits and move towards oppositely charged electrode. On application of electricity, the molecule splits into different ions and move towards different oppositely charged electrodes. That is known as electrolysis. So the movement of ions towards oppositely charged electrodes on application of electricity is known as electrolysis. Lysis breaking, electro means electricity. So on application of electricity, the breaking or the splitting of this molecule takes place. Actually, whenever we take the ionic compound, there are always this in aqueous solution. We take ionic compound in aqueous solution or in molten state. Already they are present in ionic form. But if the electricity is applied, then the ions move towards oppositely charged electrodes. Okay, so we can say the chemical decomposition of an electrolyte and movement of ions oppositely charged electrodes on application of electricity is known as electrolysis. An application of electricity is known as electrolysis or electrolysis. And the electrolysis takes place in the device that is known as or in the instrument that is known as your electrolytic cell. The electrolysis takes place in a device. In the device is known as electrolytic cell. So this electrolytic cell consists of the device in which electrolysis takes place is known as electrolytic cell. So this electrolytic cell consists of electrolytic tank. This is called electrolytic tank, which contains some electrolyte. Two metallic rods are dipped in it. And these metallic rods are connected through conducting wire. So these are connected through wire, through a battery, external source of electricity. So not visible. 1 minute. The electrolysis takes place in electrolytic tank, and it contains some electrolyte. And these electrolytes, these are dipped in, two electrodes are dipped in it, and these electrodes are then connected through conducting wire, and external source of electricity, battery, is connected to it. Okay, so the electrode which is connected to the positive terminal of the battery, that is known as your anode, and which is connected to the negative terminal of the battery, that is known as cathode, and this is your electrolyte. Okay, so this is your conducting material, the conducting wire. This is battery, the external source of electricity, and these are two metallic rods, that is called electrodes. Two metallic rods, this electrodes. This is your electrolyte, and this is your electrolytic tank, and overall this is called electrolytic cell. This is called your electrolytic cell. Okay, so when this electricity is passed through them, and what is the electrolyte present here, that generally decompose to give two oppositely charged ions. So it gives two opposite charged ions, positive ions and negative ions. So the positive ions or the cations that move towards positive ions or these cations move towards this cathode. While the negatively charged ions that move towards anode. Negatively charged ions move towards anode, and the positively charged ions that move towards cathode. Okay, and they lost their charge, and here, so the ions move towards oppositely charged electrodes, cations move towards cathode, anions move towards anode, and there they lost their charge. And what is the some chemical reaction takes place. So some primary changes or secondary changes. They lost their charge, so primary changes takes place, and if the primary changes atoms or this species is unstable, then it may undergo secondary change to form any other molecules. Okay. So what is the product formed in this electrolysis? That depends on two factors. One is that is your type of electrolyte used. Type of electrolyte used, and another type of electrode used. Type of electrode used. Type of electrolyte used and the type of electrode used. Let us consider some example. Electrolysis of molten sodium chloride or fused sodium chloride using graphite electrode. So this graphite electrode is inert electrode. It does not react with this electrolytes. Electrolysis of molten sodium chloride. So molten sodium chloride NaCl decomposes as Na plus and Cl minus. Then what happens at cathode? So cation should move towards cathode and that should lose their charge. Here the cation is Na plus at cathode. Na plus electron. Here the cation move towards this and they receive electron from this cathode. They receive electron from the cathode and lost their charge. In this Na plus move towards cathode and receive electron, it forms Na plus. So Na plus electron give rise to Na. Sodium metal is deposited here and what type of reaction? This is gain of electron. Here reduction takes place. Reduction reaction takes place. At cathode reduction takes place. Similarly, what is the reaction takes place at anode? This is the primary change. At anode, the anion, this is the anion, and anion should move towards anode. Anion should move towards anode and it should lose its charge. It gives its electron to this anode, so it should become lost its charge. So in this way, Cl minus electron, it gives Cl. And this Cl is unstable. It forms a free radical of chlorine atom. And this is what happens, a loss of electron at anode, your oxidation takes place. Oxidation takes place. And this is the primary change, it is unstable and Cl plus Cl give rise to chlorine. So in this way, when this electrolysis of sodium chloride takes place, then sodium metal deposited at cathode and chlorine gas is liberated at anode. Okay, so this is the electrolysis of sodium chloride. Now let us take example of another, that is electrolysis of aqueous solution of sodium chloride or sodium chloride solution. Electrolysis of sodium chloride solution. Electrolysis of sodium chloride solution or aqueous solution of sodium chloride. So when sodium chloride solution is there, so first sodium chloride being a salt, it ionizes completely, almost completely to give Na plus and Cl minus, and there is also another electrolyte, that is water, that is ionizes slightly to form H plus OH minus. Now look here. So when electrolysis takes place, so there are different first breaking takes place like this, Na plus Cl minus H plus OH minus. There are two types of cation and two types of anion. So these two cation move towards cathode and these two anion move towards anode. Then what will happen? So in this case, whether these two cathode will deposit simultaneously or whether these two anion move towards anode simultaneously and lost their charge, actually what happen? So if in a solution there are different types of cations and different types of anions present, then these ions compete among themselves to lose their charge, to get discharge. So these ions compete themselves to get discharge. So among them, which has low discharge potential, which require a low discharge potential, which require less energy for their potential to discharge, that will discharge faster. So that is known as your preferential discharge theory. That depends on preferential discharge. Okay, so that depends upon that is preferential discharge theory. So what is that? Among these cations, the cation which has low discharge potential, that will discharge faster, or that will prefer for discharging. Similarly, in case of anion also, which has low discharge potential, that will discharge faster. So, for example, if different cations are given, then the cation which has high standard reduction potential, the cation which has high value of standard reduction potential, that will preferentially discharged, or that has low discharge potential, that will preferentially discharged at cathode. Similarly, among the anodes which has a low value of discharge potential, that will discharge at this anode. So in this way, a few examples are there. So for in case of some cations, the preferential discharge order of some cation is K plus, Ca2 plus, then Na plus, Mg2 plus, Al3 plus, Zn2 plus, H plus, Cu2 plus, Ag plus, Au3 plus. So this is the preferential discharge order, increasing order of preferential discharge. Increasing order of preferential discharge in case of cations. Similarly, in case of anions, sulfate, nitrate, hydroxide, chloride, bromide, iodide. This is the increasing order of preferential discharge. Okay, so this is the increasing order of preferential discharge for anions, and this is for cations. Look here. NaCl, Na plus Cl minus, H plus OH minus. Between Na plus and H plus has, this is preferentially discharged part. This has low discharge potential, or we can say this has high standard reduction potential, or this has low discharge potential. As it has low discharge potential, it will discharge fast than Na plus. So between Na plus and H plus, these two will compete. So if the two will compete, then H plus will win and H plus will discharge fast and here. So in this way, remember this, okay? So in this way, what will happen at cathode? So at cathode, H plus electron give rise rise to H, and this is your what? Reduction reaction. Okay, and primary change, and H plus H give rise to H2. Similarly at anode. So what are the ions? Cl minus and OH minus. Between Cl minus and OH minus ion, Cl minus ion has low discharge potential. In this way, Cl minus electron give rise to Cl, that is your oxidation. Okay, and Cl plus Cl give rise to chlorine. Okay, so chlorine gas will be liberated at anode, and hydrogen gas will be liberated at cathode. At cathode, hydrogen gas will be liberated, and chlorine gas will be liberated at anode. And the solution contains now Na plus and OH minus. Na plus and OH minus. So after some time, the solution becomes what? Your alkaline, and the pH value of the solution increases. And the pH value increases, and it becomes basic nature. This pH value increases. Okay. Now let us take another example. So in this step, what are the product form that depends on the type of electrolyte used. Okay. Now let us take another example of electrolysis of copper sulfate. Electrolysis of copper sulfate using platinum electrode. That also depends on type of electrode used, that is your active electrode and inert electrode. This is platinum electrode, also known as inert electrode. So this graphite, platinum electrode, these are graphite and platinum electrode, these are inert electrodes, and these inert electrodes do not react directly with this electrolytes. Okay, so electrolysis of copper sulfate. Solution: copper sulfate solution using platinum electrode. Look here, so copper sulfate CuSO4 gives you Cu2 plus SO4 2 minus, and there is also water, and this is the water solution, H plus OH minus. Okay, between Cu2 plus, next what happens at cathode? So between Cu2 plus and H plus, these two will compete with each other, but Cu2 plus has higher reduction potential, or it has low discharge potential, or preferentially it will be discharged than that of hydrogen. And have given the preferential discharge order. So a few cations, so Cu2 plus and H plus. Cu2 plus has a low discharge potential, or we can say it has high reduction potential, or it has a low discharge potential. Preferentially, in this way, it will preferentially discharge first than this. So at cathode, Cu2 plus 2 electron give rise to Cu. Okay, so gain of electron, that is your part of reduction, that is your reduction reaction takes place at cathode. Remember, always reduction reaction. Next, what happens at anode? So there are two ions, sulfate ion and hydroxide ion. So among sulfate ion and hydroxide ion, this hydroxide ion has a low discharge potential. So which has low discharge potential, that will discharge first. Between sulfate and hydroxide, hydroxide ion has a low discharge potential. In this way, at anode, so when these two compete, OH minus will win. So OH minus electron give rise to OH. This is your oxidation process, and this being unstable, this is the primary change, and primary product is unstable. In this primary product, again it reacts to give 2H2O plus O2. So it decomposes to give 2 water and O2. So in this way, when electrolysis of copper sulfate solution takes place, then copper will deposited at cathode and oxygen gas will be liberated at anode. Okay, and the resulting solution. Now these two gone, Cu2 plus OH minus, and now the resulting solution contain H plus and SO4 2 minus. So the solution now becomes acidic and the pH value decreases. As the solution becomes acidic, the pH value decreases. Okay. Next one. So this is electrolysis of copper sulfate solution using platinum electrode. That is an anode electrode. Then what happens when electrolysis of a solution takes place using an active electrode? So electrolysis of copper sulfate solution. Electrolysis of copper sulfate solution using copper electrode, that is active electrode. So the active electrode is that one which reacts with these electrolytes. Okay. So what happens? So CuSO4 give rise to Cu2 plus SO4 2 minus, and water gives what? H plus and OH minus. Then at cathode, so these two compete, and Cu2 plus win and Cu2 plus 2 electron give rise to copper. Then what happens at anode? So if an active electrode is used, so these two electrodes are this anode and cathode, both are made of this copper. Okay, when this active electrode is used at anode, then what happens? Instead of this sulfide and hydroxide will go towards this anode, what happens? Same amount of copper, the amount of copper will deposited at cathode, same amount of copper goes into solution. Here, instead of the oxidation of sulfide and hydroxide, oxidation of copper takes place. Here, instead of oxidation of sulfide ion and hydroxide ion, oxidation of copper metal takes place. Okay, so oxidation of copper means copper here loses electron. Instead of sulfide and hydroxide, if an active electrode is used, then the active electrode loses its electron. In this way, oxidation takes place, but copper here loses electron. Cu give rise to Cu2 plus 2 electron. Same amount of copper will goes into solution. It forms the electrolyte. Okay, so it forms the electrolyte. Same amount of copper. The sulfate ion comes here, and the sulfate reacts with this copper to form this copper sulfate. We can say the sulfate combines with this copper to form copper sulfate. That means Cu is converted to Cu2 plus 2 electron. So here reduction takes place, and here oxidation takes place. Okay, Cu give rise to Cu2 plus 2 electron. So in this way, so now the Cu comes to here Cu2 plus. Again the Cu2 plus come here and deposited here cathode as copper electrode. So in this way, the weight of this cathode increases and the weight of anode here decreases. Weight of anode decreases and the weight of cathode. So the cathode gains its weight and the anode loses its weight. Okay. So this is the reaction takes place when electrolysis of copper sulfate takes place using copper electrode. And the solution, now the pH of the solution do not change here. It remains constant. Okay. No change in the electrolyte here. Okay. So because some amount of copper comes to this solution state, and from this solution again copper ion again forms your copper metal. So this is the reaction takes place when electrolysis of copper sulfide takes place using active electrode copper. Next, what happens when electrolysis takes place? When electrolysis of silver nitrate solution takes place using platinum electrode. Electrolysis of silver nitrate solution using platinum electrode. Okay. So silver nitrate AgNO3 give rise to Ag plus NO3 minus. Similarly, water gives H plus OH minus at cathode. There are two cations, Ag plus and H plus. Among them, Ag plus has low discharge potential. It will preferentially discharge than H plus ion. In this way, Ag plus electron gives silver. Here, reduction takes place. This is the primary change. Similarly, at NO. Between nitrate ion and OH minus ion, this OH minus hydroxide ion has less discharge potential or low discharge potential than the subnitrate. In this way, it will preferentially discharge. So OH minus electron give rise to OH. This is oxidation process, and 4OH give rise to H2O plus O2. So oxygen gas will liberated at anode and silver metal will deposit at cathode. Okay, so silver metal deposit at cathode and oxygen gas is liberated at anode. And these electrolyses are helpful for metallurgical process for refining of metals. So in this the crude impure metal is generally made anode, and the pure metal is made some pure strips of metal made your cathode. In this way, when electrolysis takes place, from this anode the metal goes into solution, and from this solution or electrolyte, this metal is deposited at cathode. In this way, to get the pure metal or refined metal, this is used in electrolytic process. So some metals like active metals like sodium, potassium, magnesium, calcium, etc. are generally extracted by this electrometallurgy process. Similarly, copper is also refined by electrolytic refining process. Okay, and this electrolysis is also helpful in electroplating or electrocoating of some metal over another metal. Okay, so this is some idea about electrolysis.